support the design flexibility and achieve better functionality. Well, there exist several examples of metal AM in construction, like from the large-scale printed bridge in Amsterdam to small components like the connection node. And however, geometry inconsistency is one of the main concerns in DD because the laser material interaction process is a very complex process and are easily influenced by different factors. So often failure cases will occur, and geometry inspection after manufacturing cannot, it's too late. It cannot inspect the geometry defects, and even though it can detect, it is also hard to compensate or repair. So in this research, we propose a real-time geometry assurance methodology to inspect the geometry defects during the DD printing process. And here are the framework. With process input, which is the printing parameters, the manufacturing process will begin, and we developed a process monitoring technique to both extract monitor the geometry attributes and measure some important uncontrollable process parameters. And then with the geometry attributes, we can quantify the geometry discrepancy. And for such geometry discrepancy, we need to compensate through geometry control, which is to adjust the printing parameters. And to know what value should we adjust, we need to establish the relationship between process parameters and geometry attributes, which is the geometry estimation task. So here are some of the results of this three parts. First, for the geometry monitoring, we have established a geometry monitoring system with a lens scanner to measure the geometry, and the IR camera to measure the process parameter, which is the manifold temperature. Then for the relationship establishment, we considered additional process parameters and also using advanced neural networks to improve the performance. And we're focusing on the problematic corner area. And finally, for the geometry control, we have developed geometry control method to validate our proposed method. Yep, that's all. Thank you.